Hello everyone, I'm Xiao Gang. In the last lesson, we wrote the server-side interface. Now we will write the client-side interface. First, on the server side, we need to copy the structure used for network transmission in the request. Let's just copy it over. Then go to a client plugin. Also, this file. Extract this file. After extracting it, let's check if it should compile successfully. Let's compile it. Then we need to send this HTTP request. There's a compilation error here. This is because our tool does not have the tool class name here. This is because this class hasn't been copied yet. So let's copy this class over as well. We can copy this directly because when we wrote it back, then we made it completely decoupled in this way. So this file can be directly relied upon. The CPP here is in this location. So now let's come back and take a look at ours. Compile it again. It should compile successfully now. Okay, so after it compiles successfully, this color didn't get applied. We'll just ignore it. It doesn't affect our usage. Then we go into the subsystem. Into the subsystem. We go to this place here. There is a checkivation here. We need to write our code here to send this login request. Okay, let me handle this color. Okay, the color has been restored on our end. Similarly, we also need to write a method here for our bplabber to call, right? I'll just copy it over here. And here we need a request data. And we need a delegate. We'll still write our delegate in this position. Write it in this position. Obviously, the delegate follows the same format. And here we have 5 parameters. Let's change it to 5 parameters. It should be 5. As for the first 2 parameters, we'll bring them in. That is describing our asynchronous action. These 5 parameters of its request type. Then for the following parameters, actually, first there is a boolean, whether it was successful. Then its specific response type, whether it is a success or something else. Then there will be an additional struct here. This struct is the data we need to return. We don't have it yet, right? Then we still need to go to our place here, to our score. Here we reflect this response. This is the data returned by our login. We copy it over and put it here. Okay, put it here. Good. After we come back, it should be fine here. Let's compile it first. This place prompts it. Funchip area, miss variable of tabline. Let's check it. Did we make a mistake here? Somewhere. It should be each R, sen, 2, we, indeed, 5 parameters. It should be that we didn't include this header file. So let's include this header file. We probably haven't used this recipe's data here before. It should be normal now. It's still not normal. Let's check again. This name probably needs to be changed. As long as this name matches, it's fine. Let's compile it again. Check the number of commas here again. Okay, good. Then it should be normal now. This line is a bit long. Let's hit enter to make it easier to read. Okay. So it's roughly these 5 parameters, right? It just has one more piece of data compared to it. Then, at this point, go back to our subsystem. These 2 things are what activate our parameters. Then let's create its specific implementation. Okay, after creating the implementation, we should first write the library. Actually, just write the beep library below. For this library, we'll copy its function signature over. It's actually an interface we use for login. This signature still performs login. And here we can change the keywords. Change the name here. Also, get the world context. This place needs data to be passed in. That is our request data, which is your username and password. After passing it in, we'll create its implementation. This implementation is actually very simple. You can directly copy this code over. Then, when we use the second one here, we also call its login. Then here we sign the parameter login. The first one passes this, and the second one passes the delegate we want to execute. Okay, then we execute it specifically here. Now let's start writing the implementation inside. As for the specific implementation, it's actually the same implementation method as the checker vision we wrote above. We'll still do it step by step. First, step 1, we need to verify whether the data is correct. Let's prepare a return result first. Then we need to use a verification method from our struct. The returned result should be this. Change the name. So let's take a look whether this is a correct piece of logic PT. Okay, this part is called transaction. In the previous lesson, we wrote that for a transaction, its user and password are this, var, guy, and password. And here, the transaction here, we distinguish whether it is on the client or on the server. So here, because the client gets the code is 6 to 18, we need to encrypt this code. So this is considering the client's education method. What the server receives should be this encrypted thing. If it does not have the correct data, then it proves that this login request is invalid. Then we need to hit return here. There is no need to execute further. Then we need to prepare this login data. You can see, then prepare a piece of data because this struct is invalid. But we need to return it. So that's it. Just prepare an invalid data to return because we have false here. Then here we need to pass the type of his request. Obviously, the type of request here, it is a login. So here we write login. It is login. Then it's assigned ID. Check the assigned ID. As for this ID, we need to declare this ID in advance so that we can use it. Okay, we have prepared such an ID. Then pass this ID out as well. Okay, in this way, the front can receive this result. Then, after the data transaction is completed here, we need to obtain the local server configuration. So we refresh the local configuration. It should be here. This code should be the same. It's just that the proxy it executes is different. First, if the local configuration execution fails here, then we also need to prepare some data. We can just copy this part directly. This part returns this type. Then parsing the local server port failed. Then request, then ID, then data. Okay. Next, we put this local proxy in. Then we need to prepare a proxy of this trade. Because this proxy, we will use it later when making the callback, making it very convenient to use. Okay, because we need to save this proxy now because this is asynchronous. So we need to save it. After saving this proxy, if we want to reverse the data virtually, before reversing it, we first need to process this data with MD5. So we need to write an MD5 method. Because right now, we might just have a simple MD5. We may, depending on the need, we may need different MD5 methods or encryption methods. So here it should be hashed out. Therefore, we provide an MD5 password here. Because later, if you want, in normal commercial use, you should use the public key encryption method. This is the most secure. We don't have time to write this here because it will be written for you later. So there's no need to repeat and copy these contents here. Okay, so after having such an MD5 method, we go back to the top. Then the password here has already been encrypted. Once encrypted, it becomes a sense-hour piece of data. Then next, we prepare a payment string. A payment string for a connection. Then we pass this data to it. This is secondary data, secondary service data. we serialize it over. You can see here, after serializing it over. Then we send our HTTP request. Then you can see our request here. We need to check how this request interface is written. The first is the request type. The second is JSON. The third is GUID. So for the request type, we just need to change this part. Okay, so this request is sent out. Then after sending the request, we don't need to touch the stuff in here, because this is how we send everything. Because this interface wraps secondary data into primary data, then specify the server port and the type of query. In add our authentication information. You can see, okay, so after we finish writing this, we can actually proceed to write our response. We'll just write the response directly. So this is currently warm. Only after the HTTP part here, that's it actually reach. That's it for now. Actually, this is the first step. Dispatch comes in. After coming in, it enters dispatch. HTTPST. At this point, it reads the request. Then we take the data. This is the first level data. We pass the relevant things in the first level data. In the first level data, there will be a request type. The request type is parsed out here. Right here, the request type here is first level data. Then in this place, it is based on each round in its primary data to perform a secondary data distribution and forwarding. Processing like this. Okay. Then here we continue to update our login server response. Then next we go to our second step. We look at the third step. The third step is where we handle the response earlier. Okay, here we perform a distribution process. Okay, we haven't written the login part here yet, right? Now we just write the login part. Okay, this response type here is a login response. We put it here. And remember to write break. Remember to write break. The processing method here is also very simple. First, we can paste this here. It should also be possible. Let's paste it. First, your delegates map should not be 0. This delegates map should not be 0. Then you look for this delegate inside it. We can change the name to log delegate. Then we directly execute this log delegate, and when it executes, actually, let's see what kind of data it returns. It should have a response state. Call serial response. So here we actually need to write more of this, because we have data that needs to be returned to it. So first we find this delegate. At the same time, we need to obtain our secondary data, because this place requires secondary data. So we prepare a USP data for the secondary data, then we serialize this secondary data here. If the serialization is successful, then we serialize the string into the struct. After this succeeds, we can return the request type, the delegate ID, its result type, and the login recipe data back. If the serialization fails, then this situation is quite strange. Then we need to still return this set of item, but when returning, we need to return these two. That is, this should be false. This one false. Its first level data is successful, but its second level data actually failed. This place is very strange. We will give it a prompt. That is, parsing the server's second level data failed. Okay, then after completion, our proxy is handled. Okay, then after handling it, we indeed remove this proxy. Okay, no issues here. So this is a very correct response handling. But sometimes we may not have a network. If there is no network, we need to remove it here. Because when you have no network, it actually won't have this at all. It won't go into this part. So it won't reach our first level. That is, if you have no network, you don't even have first level service data. This part cannot take effect. So you need to handle it here. The handling here is also relatively simple. First, the proxy container must not have elements. Then we directly execute it here. That's fine. Okay, when executing here, it also requires we can move down a bit. Requires a UEC fixed type. That is what kind of request it is. Here it would definitely be a failure. Then pass this ID out as well. This ID is unique to this one-step action, then it will definitely fail. As for this result, it is actually handled by us above, whether it's a network failure or a parsing failure. This data is invalid data. We just put it here. After we finish executing, we just remove it. Okay, so our client interface is written. Next, we will test it for everyone. Then we also start our server. Let me check what the initial account for our server is. It's 123456. Right. Then we also start the server. Then the server is started. Then we wait for the client. Actually, we have completed A, B, and C. Now we just need to complete D. Actually, in phase C, we started extending our interface. In phase C, we actually wrote the server interface for this login. In phase D, we are writing the client interface for this login. Yes. Our server is working normally now, and we have also launched the client. In this level, we didn't write the UI for everyone. Writing this UI is a very simple, small thing. There's no need to waste everyone's time writing this UI. We'll just test it quickly. Okay, next, we'll use let's still use this one-click method. Find our method. At the same time, we need to prepare a piece of data. We'll make this struct. What we provide first is this 小岗 1, 2, 3, 4, 5, 6. Note that when comparing strings, this case sensitivity, we can try it later. Then we add login RSP event. This string is not correct. We need to spell it. Let's use this one. Take a look. The string here is not correct. Okay, let's use this one. Here we first print out the request type in this async ID. The result reflected enum. Okay, then this is fine. Then in this way, we can directly obtain this result. But for the specific data information, we need to break open this struct to see it. So, break open this struct. If we succeed, we will return this username's ID and its name. Then we also prepare this one. We remove it. We only need 4. It's UALM and ID, right? WARM. Okay, this is UAIID. Let's print it out. Okay, now let's demonstrate it for everyone. Let's test it. Obviously, it failed here. The request failed. Let's see what this failure is. Failed. Your land was long. Let's see why he failed. Just right. Failed. The server side failed. Let's set a breakpoint on the server side and check. 小岗 1, 2, 3, 4, 5, 6. Check if it's written incorrectly. We've reached the server breakpoint here. Let's just set 1 right here. It should be here. Handle logo. Let's check here, and it's convenient for us to connect the lines. Hey, the server breakpoint doesn't seem to have hit. The reason it didn't hit is let's set another breakpoint outside and check. Hey, it's in. Good, let's step through it. Let's go in. This place, it just skipped over it. Let's see why it jumped over there. This one didn't lift. Obviously, in this place, the server wrote it in the wrong position. This is very simple. We just need to change it. Because we are making the login, we just need to restart the server. This place is a timeout. You can set the HTTP timeout time. This is also not a problem. Okay, let's test again. Test again. We'll just let it through now. It came in, and then it says incorrect username or password. Incorrect username or password. Let's check what's causing the incorrect username or password. The server crashed again. Let's open it. Okay, let's take a look here. Click it, and then after we come in, we go directly here. Okay, so here we need to verify whether it is appropriate. It verifies that the password here expires. That is to say, what's inside here expires. Let's check what the reason is. This reason is actually a very common mistake, because when we iterate like this, we push it out. You will find that although there is data here, but you can tell at a glance with this data, you will find that the data here is missing. The reason it's missing is actually very simple. It is above. When we use this method above, we're actually miswriting it. Missed writing a reference symbol, because here it's better if it passes a reference here. You need to receive it with a reference. Otherwise, modifying this will cause errors. That's why sometimes I don't like using references. That is, we can directly add it in. Just don't use this kind of syntax. This syntax is more advanced. It's normal to make small mistakes sometimes. Let's press it. Okay, now if we handle it, it should have succeeded today. You can see it succeeded here, right? It has been demonstrated to everyone. Now let's take a look on our client side. The login request here, the device ID is this, and then it succeeded. It succeeded without any issues, right? So our real login interface is successful. Now we can try changing the password here, or something like that. Because this interface, since it was actually written separately, you need to check if everything is okay. So let's change it to lowercase. Let's see if it can succeed. Because there might be a case sensitivity issue here. Okay, if you look at this result, so quotes full should be, maybe in this case, it is case sensitive, possibly. Right, then change it back. You can see, test it. Okay, anyway, when you compare strings, you must pay attention to this case sensitivity issue. Because flam is case insensitive. Okay, so this character is not something you can glance at. It is case sensitive. Then here, we can change the password and try again. Try the password. Right, see, no problem either. Then we shut down the server here. We check if there is a network anomaly. Will there be any issue? Hey, there is a network anomaly here. It also prompts slide arrow. Right, okay, we'll stop the login interface here. This concludes our lesson for today. Thank you everyone.